Hello everyone. So now we will discuss last part of atomic structure where we'll discuss about that orbitals. After that we will discuss quantum number, types of quantum number, principal quantum number, angular quantum number, magnetic and spin. And at last we will discuss electronic configuration where we'll discuss about N plus L rule, Aufbau principle, Pauli exclusion and Hund's rule. So let's start. First we will discuss orbit and orbitals. What is the difference between orbit and orbital? So orbital, we know that it is most probable area or most probable region where finding of electron is maximum, right? So here you can see electron probability of finding electron is maximum 90 to 95%. Orbital is not definite path for the electron because electron having wave nature. Next, orbit versus orbital. What is the difference? That orbit is the circular path, whereas this is probable area or region where finding of electron is maximum. It is planar, means it is 2D, whereas it is 3D. That already in a wave mechanical model we saw that electrons revolving in a spherical polar coordinate. Here maximum electron is 2n square in any orbit, whereas in any orbital maximum electron could be 2, not more than 2. Each orbit shape is circular only, whether first orbit, second orbit, any orbit. Whereas orbital shape is different. That S-orbital is spherical, P-orbital is dumbbell. Orbit is non-directional in character, but orbitals except S-orbital remaining all are directional like px, py, dx square, y square, dx square minus y square, so and so forth. This is not consistent with Heisenberg uncertainty principle, whereas this one is consistent with Heisenberg uncertainty principle. Moving further, now we will see that shapes of orbitals. So here that S orbital having a spherical shape, it is symmetrical in all direction, it is non-directional in nature because of its symmetricity, and it is close to the nucleus, having lowest energy, most stable, and maximum 2 electron can be filled. Next, p orbitals. So p orbitals having dumbbell shape, and this is px, this is py, and this is pz. This all three are directional, means it having direction. So in p subshell, how many p orbitals will be there? 3 p orbitals, means maximum how many electrons can be present in orbital? That 2. So overall in subshell how many? 2 into 2, 2 plus 2 plus 2. Total how many? 6 electron. Next, coming to d orbital. So d orbital is double dumbbell shape. So it having, you can see that two types of orbitals. One is axial and one is non-axial. So dxy, dyz and dzx, they are non-axials, whereas dx square minus y square and dz square, they are axials. Like here you can see this one is non-axial. This all those lobes are not present on axis, so they are non-axials, whereas here you can see this is present on axis, so they are called axials. Here you can see this is dz square, so z lobe is present on z axis and one circular ring is there in xy plane. This is also called baby Suther, and this both are axial orbitals. These three are non-axials, but this all 5 orbitals are degenerate orbitals, means their direction different, orientation is different, but energy wise they are same. They are called degenerate orbitals. Next, f orbitals. So f orbital shape is very complicated. We'll just consider like leaf like shape. So here it having 7 orbitals in f subshell. So this is q, y q, z q. Similarly, x into y square minus z square, y into z square minus z square minus y square, fz into x square minus y square, and xyz. Next, degenerate orbital. Degenerate orbital means that in any subshell that orbitals having same energy, they are called degenerate orbitals. And degeneracy is only maintained in the absence of magnetic field. In presence of magnetic field, its degeneracy will be lost. Like we discussed that in presence of ligand, how that d orbitals breaking in T2G and EG. Similarly, now here you can have a glance of this all those orbitals. Like here this is px, so it having one nodal plane. Similarly, py and pz having also one nodal plane. Here you can see dz square having conical nodal plane, as I discussed. Similarly, here also conical nodal plane. Remaining all d orbitals having how many? Two nodal planes, where that plane where probability of finding electron is 0. Similarly, you can see this all those are f orbitals. Just you can see their shapes are very complicated. So now moving further, now we will study quantum numbers. So quantum number is telling that details about that electron where it is present inside the atom. So it is set of 4 quantum number. Out of 4, 3 quantum numbers is derived from Schrödinger wave equation. We know that psi function is function of n comma l comma m. So principal quantum number is governing all other remaining 3 quantum numbers. That's why it is called principal quantum number. Is telling size of electron wave, is telling radius of that Bohr orbit, velocity of that electron in that, total energy of electron in Bohr orbit, potential energy, kinetic energy. So n having in a quantization of angular momentum, mvr is equal to nh by 2 pi. Wherever there is n is coming, means principal quantum number importance is there. Correct? So that it describes the size of electron wave, total energy of electron. And here you can see if n is equal to 1, so it having, always remember that inside atom what is there? Shell is there, or that cell is there, or energy level is there. Inside cell what is there? Subshell is there. Inside subshell what is there? Orbital is there. And inside orbital what is there? Electron is there. So here that first n is equal to 1 means first cell in that one subcell. If n value is 4, then how many subcell? 4 subcell. Means number of subcell present in n number of cell is equal to n. If 4n is equal to 4, so how many subcell? 4 subcell. Number of orbitals, orbital is present in subcell. In nth cell is n square. Yes. In S, how many orbitals will be there? 1. In P, how many orbitals? 3. Px, Py and Pz. In D, how many orbitals? 5. Dxy, dyz, dzx, dx square minus y square, and dz square. Similarly, F having 7. So 7 plus 5, 12. 12 and 3, 15. And 15 and 1, 16. So 4 4 ja 16. Next, maximum number of electrons which can present in principal energy shell means in any cell is equal to 2n square. Means in each orbitals, already we discussed that maximum how many electron? 2 electron. So total orbitals are how many? N square. So total number of electrons will be how many? 2n square. No energy cell in atom of known element possesses more than 32 electron. Means any cell will not it will contain more than 32 electron. For each orbital, its angular momentum mvr is equal to nh by 2 pi. Means that electron which is revolving, its angular momentum will be integral multiple of h by 2 pi. Next, coming to second, Azimuthal quantum number, which is proposed by Sommerfeld, and it is also called angular quantum number or subsidiary quantum number. So what it is defining? It is defining shape. There it was defining size. So it is defining shape of electron cloud, because electron is like a wave. So it is defining shape of electron cloud and number of subcell in the cell. And its value depends on L. So it will be 0 to n minus 1. That is the range. So here you can see for any S, whether it is 1s, 2s, 3s, for any S subcell, its L value will be 0. Similarly, for any P, 2p, 3p, 4p, 5p, 7p, whatsoever, its L value will be always 1. Similarly, for any D, 3d, 4d, L value will be 2. And for any F, L value will be 3. Here that number of orbitals in subshell. So number of orbitals we have to tell in subshell. So how many? 2 into L plus 1. There we discuss number of orbitals in shell, that is n square. Here number of orbitals in subshell, that is 2 into L plus 1. So just remember this, all those formula. Maximum number of electron in particular subshell, hardly 5-6 formula. So you just write at one page, and that in one page, and revise 4-5 times. So number of orbitals in subshell, how many? 2L plus 1. In each orbital, how many electron? 2. So maximum how many electrons will be present in any subshell? 2 into 2L plus 1. Clear? This is maximum number of electron present in subshell. There we discussed that maximum number of electron present in orbital, that is 2n square. Next here, there we discuss or that angular momentum of orbit. Here we are discussing angular momentum of orbital. What it is? H by 2 pi under root L into L plus 1. Okay, H by 2 pi is also considered as H bar. Now for S orbital, we know L value is 0. So it's that orbital angular momentum also will be 0. For any P, L value will be 1, means it will be 1 into 1 plus 1 means 2. So root 2 into H by 2 pi. Similarly for D, it will be root 3 H by 2 pi. Next, coming to magnetic quantum number. So magnetic quantum number define or related to orbitals. So it tells the orientation of that subshell, means how that px, py and pz or any d orbitals also will orient in a space. So it can have value, its value depends on L. So its range is minus L to plus L including 0. So total L value will be, total that it value will be how many? That magnetic quantum number 2L plus 1. So here you can see S orbital has one, S subshell having 1 orbital, P subshell having 3 orbitals, D orbitals having 5, and similarly F orbitals are 7. Next, coming to spin quantum number. So electrons as rotating, so if it will be clockwise, then it will be plus 1 by 2, and if it is anti-clockwise, minus 1 by 2. Similarly, this one is very important formula, is spin magnetic moment only. So mu is equal to under root n into n plus 2 Bohr magneton. Here be very careful, this n is not principal quantum number, this n is number of unpaired electron. Next is spin angular momentum. So spin angular momentum is h by 2 pi. There it was in that orbitals, it was L into L plus 1. Here it is S into S plus 1. S is what? Spin multiplicity. Now here maximum number of spin in any atom, just half into number of unpaired electron. So here you can see that, so maximum question you will get on this only, okay, this formula, and then after at last some questions on this, very few on this, but you can keep all those formula in your mind. Next, Here let's suppose example we are taking. Inside atom was what is there? Subshell. Subshell is related to principal quantum number. That cell subshell is related to that angular quantum number. Orbital is related to magnetic quantum number, and electrons spin. So here that first cell or first energy level, in that how many subshell? S subshell. In that how many orbitals? S orbital, a small s. In that how many maximum electron? 2. Similarly, in second orbit, how many subcells? S and P, 2s and 2p. In that how many orbitals are there? S and 3p, px, py and pz. So S having how many electron can be maximum filled? 2. P having how many? 6. So total how many? 8. Similarly, M shell having how many subshell? S, P and D. So S having how many orbital? Only 1. P having 3. D having 5. So total 18. Similarly, N having subshell S also, P also, D also, F also. Similarly, again total here how many orbitals? That F having 7, D having 5, P having 3, S having 1. So total how many? 32. So this is. Next, moving further, what is the total number of orbitals associated with principal quantum number if n is equal to 3? If n is equal to 3, so here you can see if n is equal to 3 means L value will be n minus 1. So it will be 0, 1 and 2. If L value is 0 means magnetic quantum number also will be 0. If L value is 1 means range minus L to plus L including 0. So this is L value is equal to 2 means magnetic quantum number minus 2, minus 1, 0, plus 1, plus 2. You know this magnetic quantum number describes about orbitals. So how many orbitals are there? 1 here, 3 here and 5 are here. So total how many? 9 orbitals. So we can do by this also raw method, or we can apply formula that we know number of orbitals is equal to n square, or number of orbitals another formula 2l plus 1. So here L value 0 because inside 3 it is L. Inside 3 only this is 1, inside 3 only this is 2. So for each we can calculate 2l plus 1. So it is 1, 3 and 5, total 9. Next, another question that orbital's angular momentum of an electron in a particular shell, it is how much? Under root 5 h by pi. Then find maximum number of electrons which may be present in subshell. So orbital's angular momentum of an electron. So what it is given? Orbital's angular momentum. So orbital angular momentum is equal to formula we know, h by 2 pi under root L into L plus 1. So from here this one we are, so here this we are equating. So on equating you can see here h by pi cancelled. So this 2 is going that side. So 2 root 5 is equal to this. So applying root square both sides. So L value is coming 4. So if L value is 4 means maximum number of electron in shell will be how much? 2 into 2L plus 1, 18. Next, here it is asking very famous question that which of the set of quantum number is not valid. So yes, if n value is 3, so L value should be n minus 1. Yes, it is 2, correct. And magnetic quantum number will be minus L2 plus L. Means here you can see 2. Okay, this is also suitable, correct. Spin is half. Yes, this is also correct. So A is correct. It means it is feasible. Next, n is equal to 2, L is equal to 0, M is equal to 0. Yes, S is equal to minus 1 by 2. This is also correct. N is equal to 4, L is equal to 2, M is equal to minus 1, S is equal to plus 1 by 2. Yes, it is correct. N is equal to 4, correct. L is equal to 3, correct. M is equal to 4, wrong. M is minus L2 plus L including 0. So D is the wrong option. Next, moving further, Now we will discuss last segment, electronic configuration. So electronic configuration, in that first Pauli's exclusion principle, what it is telling, that any electron inside the atom will not have that all four quantum number values same. If 3 also getting same, at least one spin quantum number will be different. You can check any electron inside the atom. All 4 quantum number values same cannot be possible. Next, coming to Aufbau principle. So Aufbau principle is telling filling of electron, that how we can fill that electron inside the atom. So those orbitals which energy is less means it is more stable. So first we will fill in that, and how we can calculate its energy or stability by n plus L rule. If minimum the value of n plus L rule, then that orbital is most stable. Like suppose for example here 3D subshell is there. So 3D subshell. So n plus L rule, if it is minimum for any subshell, its energy is minimum, stability is maximum. So here 3D is there and 4s is there. So for D, L value will be 2 and for S, L value will be 0. Principal quantum number is 4, principal quantum number is here 3. So 3 plus 2, 5, here 3 plus 4 plus 0, 4. So overall its energy is less compared to 3D. So first we will fill electron in 4s because its energy is less, stability is more. If n plus L value is same, then what we will do? Then we will go for those subshell which having lower value of n. Like here you can see 3D and 4p. So 3D having 3 plus 2, 5, and 4p having 4 plus L value is 1, 5. So both having same, but in that which one having less principal quantum number? 3. So this one is having lower energy. So this is n plus L rule. And after this last Hund's rule. Hund's rule is telling that while filling electron in degenerate subshell, first we should fill 1 electron, and after that we should do pairing. That's it. Next, after that, here you can see some questions that asking that calculate electronic configuration, means write electronic configuration and calculate number of unpaired electron and total spin also. So for one example, we can see that carbon having 1s, 2s2 and 2p2. So first 1 electron we will fill. So number of unpaired electron in ground state 2. Total spin will be plus 2 or minus 2 divided by 2. So this is like that. All remaining also questions you can solve. You can just take that screenshot and attempt. Okay, similarly here you can calculate for oxygen, similarly for phosphorus, similarly for scandium. Next, moving further, this is iron and neon. Next, moving further, now we will discuss that electronic configuration that we know, chromium and copper. It's very famous, that in that it will be 3d5 4s1 rather than 3d4 4s2, and this will be 3d10 4s1 rather than 3d9 4s2. Why? Reason is that due to symmetrical distribution of electron, due to symmetricity, stability increases. So D5 is more stable than D4. D10 is more stable than D9. And another is that exchange energy. Exchange energy is what? When we are doing half filled, so this electron can exchange its position with this electron also, this electron also, this electron also, this electron. Similarly, that second electron can exchange position with third also, fourth also, fifth also. Third electron can exchange its position with fourth also, fifth also. Fourth can exchange with fifth. Means there is more possibility of exchange, and due to exchange what happen? Energy decreases, so stability increases. So here some examples are there, including including chromium and copper, that all those which having that exceptional electronic configuration. So just go through and revise multiple times. Next, moving further, Here that last question we will do, and it will give you a lot of clarity. That here you can see that, 1 minute. So here you can see that iron, calculate the number of electrons for this question when n plus l plus m value is 1, when n plus m value is 2, 3, 4, 5, 6 and 7. So let's calculate. So iron electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So now here you can see that in iron this is 1s2, so 1s2, this is 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So now here we will calculate n plus l plus m value for each electron. So like here you can see this electron n value is 1. So n value is 1. For this electron, since it is s, so l value will be 0. If l value is 0, so m value will be 0. Similarly for this electron, n value 1, l value 0, m value 0. Similarly for this electron, principal quantum number is 2. And since it is s, so l value and m value will be 0. Similarly this one. Similarly for 2p, this is principal quantum number 2, 2. So for this all electrons, principal quantum number will be 2, 2. And since p is there, so its l value will be 1, 1. But magnetic quantum number will be different. For this 2 electron, minus 1, minus 1, minus 1. Correct? Because if L value is 1, so M value will be minus L to plus L including 0. So minus L is for this 2 electron, minus M is for this 2, minus 1. 0 is for this 2 electron and plus 1 is for this 2 electron. Similarly, this one also, this one also, and this one also, this one also. So now here we will calculate n plus l plus m is equal to 1. How many electrons are there? So n plus m plus m, n plus l plus m. So n 1 plus 0 plus 0, 1. So here this 2 electron having 1, remaining all are not there. So total how many electron? 2 electron. Next, n plus l plus m is equal to 2. How many? Here this 2, total 2. Anywhere also? Yes, here also. Minus plus, this plus minus cancelled. So total here also. Total how many electron? 4 electron. Similarly, n plus l plus m is equal to 3. How many? So here you can see this one is 3 and this one is 3 and this one is also 3, right? So total how many? Total how many? Here 3 is there, then after here 3 is there, here also 3 is there, anywhere else 3 is there? Yes, here also. So total how many? 8, or either it could be 8 or it could be 7. Why? Because this electron, it could be here also, here also, here also, here also, because it is a degenerate orbital, right? So it could be anywhere. So that's why either it will be 8 or it will be 7 also. Similarly, you can calculate remaining. Similarly, you can calculate remaining. N is equal, n plus m, n plus l plus m is equal to 4. So here you can see total it is coming either 7 or 8. Similarly, n plus l plus m is equal to 3 or 4. Similarly, n plus l plus m is equal to 6. And similarly this one also. So you just calculate. Moving further, now we will discuss magnetic properties. So one substance is paramagnetic. So paramagnetic means those substance which is attracted towards the magnetic field. And diamagnetic means which is repelled by magnetic field. Paramagnetic means if substance having unpaired electron not equal to 0 is called paramagnetic. If number of unpaired electron 0, then it is called diamagnetic. How to calculate spin magnetic moment? under root n into n plus 2. N is here number of unpaired electron. Okay, so here you can see one question is given that unpaired electron is 1.73 is given, so we can just equate with this. So if it is number of unpaired electron is 1.73, so n value will be 1. You can see, you can remember this, that is visible. You can see that if unpaired electron is 1, mu value will be 1.73. If unpaired electron is 2, then mu value will be 2.8. Similarly 3, 3.87. If 4, 4.9. 5, 5.92. 6, 6.92. So here we completed completely atomic structure in detail, systematically each and every concept we discuss, so that we can perform nicely in coming our JEE exam. So thank you very much. Now we will discuss further in coming class.